This is definitely one of those topics that makes more sense once you see some examples, but we have to kind of know what we're shooting for. So as we try to find the radius of convergence of a power series around a specific center, there's one of three things that can happen. Either that radius will be finite but not zero, or that radius will be infinite, or that radius is going to be zero. Now what that means is the power series, of course, is centered someplace specific, maybe at A, and if the radius of convergence is finite, it just means from that A, you can go a little bit this way, you can go a little bit that way, and the power series and the function will match perfectly between those values, but outside of that region, it's going to be bad, 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 bad. This is kind of what we saw when we looked at 1 plus x squared and compared it to 1 over 1 minus x. There's a very finite area, negative 1 and 1, where the x values actually match up, and outside that, they're never going to match. Another possibility is that the radius is finite. That means that no matter how far you go from the center, if you have enough, if you have your power series all the way to infinity, they are going to match up. We said in class that this is true for sine of x, cosine of x, and e to the x, but we never really explained why. But the fact is that if I could take 1 minus x cubed over 3 factorial plus x to the fifth, 5 factorial, all the way out to infinity, it equals definitely the sine of x for no matter what x value you want to put in there. The last thing that can happen is the radius of convergence can be zero. This would mean that like at that center itself, the power series and the function would match, but the minute you step away from that center, it's going to be terrible. In practicality, these are not very useful power series, but it's important to recognize when that kind of thing is happening so you don't use a polynomial to represent something that's not going to be very helpful at all. So those are the three cases. Either it's finite, or it's infinite, or it's zero. And it's all going to come down to that thing we did in class yesterday, which was called the ratio test. The ratio test is what I taught you yesterday. It was looking at the consecutive terms of a power series, the later one on top, the previous one on the bottom, taking that ratio, taking the limit as n goes to infinity, and we're going to get some kind of value for the limit. And here's what happens. Either the limit is a non-zero constant, in which case we're going to have a finite value for r. We'll have this situation happening. Or maybe the limit is zero. When the limit is zero, that means the value for r is infinity. And if that limit is infinity, then the radius, I said ratio once, the radius is going to be zero. Now we still have to figure out how to pinpoint what these things are, but I just wanted to draw the connection between the three possibilities for the radius, either finite but not zero, or infinite, or zero. So good for some x's, good for all x's, good for basically no x's. And the three possibilities of what happens when you take the limit. Either the limit is a constant, in which case we have a fixed area, or the limit is zero, in which case we can go as far as we want, or the limit is infinity, in which case there's no radius of convergence. Now, when we go through an actual example, I'll kind of explain more of why this is the case, but if you're thinking, actually you shouldn't be thinking anything yet. Just watch the next example and I'll explain as I go.